Imagine you park your car outside tonight, but by morning, the temperature plummets to minus 60 degrees Celsius. Inside the engine, your oil turns into a thick syrup. Your battery loses almost all its charge, and your tires freeze as hard as solid rock. This animation shows a standard temperature scale. Once we drop past typical winter weather and hit minus 20 degrees Celsius, most standard vehicles start experiencing serious mechanical failures. Now, take that mechanical failure point and push it exponentially further. Down in Antarctica, the coldest, driest, and windiest continent on Earth, temperatures routinely plunge past minus 80 degrees Celsius. This cold acts as a relentless, active assault on any machinery left exposed to the elements. At these extremes, an immobile vehicle leaves you stranded in an environment that can kill an unprotected human in minutes. To understand why this happens, we have to look inside the anatomy of the vehicle, starting with its most vulnerable core system, the electronics. Look at this chart mapping battery capacity against temperature. As the temperature line crosses minus 30 degrees, extreme cold physically slows the chemical reactions inside the cells, sapping more than half of the battery's total power. This strain is compounded by material failure. Liquid crystals in touchscreen displays freeze and stop responding, while the copper wiring and solder joints that carry signals can become brittle enough to crack under the slightest vibration. Modern electric vehicles face an even steeper challenge at this threshold because that massive drop in battery capacity directly translates to a severely slashed driving range. These combined chemical and structural vulnerabilities mean that the more a car relies on high-tech circuitry and integrated sensors, the more likely it is to fail the moment the temperature drops. The problems continue deep inside the mechanical systems. Under extreme cold, engine oil stops acting like a lubricant and turns into a thick, useless syrup. The fuel system faces catastrophic failure next, as diesel physically gels up and clogs the delicate injector lines. Then, the structural materials give out. Plastic engine components become so brittle they shatter under vibration, and rubber door seals freeze completely shut against the metal frame. Yet, scientists and explorers have successfully driven across this ice for decades using specially modified expedition trucks. To combat the freezing, engineers install dedicated engine block heaters, swap out standard liquids for low-temperature synthetic fluids, and heavily insulate the entire fuel system. Externally, standard wheels are swapped out for aggressive track systems or gigantic low-pressure tires that float over the deep snow rather than sinking into it. Decades ago, explorers attempted this kind of extreme engineering with the Antarctic Snow Cruiser, an enormous machine designed specifically to conquer the continent's harsh terrain. Surviving the lowest temperatures on Earth requires completely rewriting a vehicle's basic anatomy. It has to transition from a standard machine into a highly insulated, temperature-controlled survival pod. So could a multi-million-dollar supercar survive the Antarctic? Almost certainly not. Their extremely low ground clearance and high-performance setups would strand them in deep snow before the engine had a chance to freeze. Contrast that with a rugged, utilitarian Toyota Hilux. With the right thermal preparation and suspension upgrades, a modified Hilux actually successfully drove all the way to the South Pole. A standard, expensive electric vehicle would similarly fail. Beyond the monumental challenge of keeping the battery warm, there is simply no charging infrastructure across thousands of miles of ice. Antarctica does not care about a car's price tag, its brand name, or its sleek design. The ice acts as the ultimate equalizer. It only respects functional, meticulous preparation. What's the coldest temperature your car has ever survived? Let me know in the comments.